And the last stage in the rendering pipeline is that rasterizer stage. So let's find out what happened inside the rasterizer in the next slide. The rasterizer stage is the last stage in the graphic rendering pipeline. So let's find out what happened in this stage. In this stage, the graphic pipeline is performed in the hardware. The hardware is the place where this rasterizer stage performs. And what is the role of this rasterizer stage? The role of this rasterizer stage is will convert the 2D vertices information from the geometry stage, and this vertices information here, including the coordinate of x, y, z, the information of the color, and also the information about texture. It will get this information from the geometry stage, from the previous stage, and then if we convert this information into a pixel information on the screen, and basically this and the color information here, the pixel of this color information will be stored or kept inside the color buffer. Buffer here means that is the place or memory that we hold a data right before it is used. Alright, I hope you understand the concept of buffer. Is used to hold the data right before it is used. So color information is stored inside color buffer, and the pixel of z value, okay, the pixel of this coordinate of z will be stored in the z buffer, and basically this z buffer has the same size as the color buffer. Beside that, the related scene will be rendered in the back buffer, and then it will be stored in this back buffer. And then the information inside the back buffer will be swapped with the information inside front buffer, which it will be store the current image being displayed. Okay, the information, the scene is rendered in back buffer. Okay, and then it will swap this scene that have been rendered with the front buffer, which will store the current image being displayed to us through screen. And basically this process will eliminate or remove the flicker, and this process is called or is known as double buffering. So what is flicker? What is the flicker problem? Flicker means here that visible change in the brightness between cycle display on video display. Okay, this problem is you will see there is a change in brightness between cycle that show into your screen. So in this figure here, I insert the pictures of this flicker problem. Okay, the visible change in the brightness of your screen. So this is the flicker problem. And all of the buffer on the system are grouped into the frame buffer. Okay, all the buffer that we have introduced in this rasterizer stage will be grouped together, and then it is known as frame buffer. How do we test the rendering pipeline bottlenecks? Bottlenecks here means that a narrow section that impede the traffic flow. So as you can see from this figure, just imagine that this is the rendering pipeline, and then there is a narrow section here that will cause the traffic jam here. So now we want to test whether there is a traffic jam in which stage. As you learned in the previous slide, that rendering pipeline is we have three stages, which is application, geometry, and also rasterizer. So we want to test whether there is a traffic jam or the flow is not smooth at which stage. So how to test that? If your CPU operate at 100%, then the pipeline is called CPU limited. That means that there is a bottleneck in an application stage. There is a flow that is not smooth inside this application stage. But what if the performance increase when all the light sources are removed? Then the pipeline is called transform limited. That means there is a bottleneck in a geometry stage. Okay, you have remove all the light sources. Okay, you already help the stage to achieve optimization, but still there is a bottlenecks, and this bottleneck is happen in the geometry stage. But what if the performance increase when all the resolution of the display window or its size are reduced? Then the pipeline is called field limited. That means there is a bottleneck or traffic jam inside this rasterizer stage.